Hello Python programmers. In this video we work through a few list comprehension exercises. These have been adapted from the website that I provided in the notebook file. You should have this notebook file. You can download it from you know where. And the first exercise is create an identical list from the first list using list comprehension. The first list is simply 1, 2, 3, 4, 5. You can tell it's a list because it's in square brackets. And if you want to do a little bit more digging, you could print out the type of that list by using the type function. And you would, of course, you would get the result that it is a type, or I'm sorry, the type is class list. And we're not doing any object-oriented programming here. And we're not going to talk about what a class is in any detail, but we just think of it as a data type. In this case, then, the data type of lst1 is a list. And I'm going to remove that print statement because we'll be printing other things and we don't need any extra output. At this point then, please take a shot at this. Write a list comprehension statement to make a brand new list. Okay, I'm back. I hope that you had some success. What we can do is lst2 equals a new list. Now we don't need to do that. We don't even need to create a variable that way. We can just start using list comprehension and fill in the syntax inside the square brackets. So how about lst equals x for x in lst1? Probably the world's simplest list comprehension expression. And then we can do a couple of print statements to build our confidence. Print lst2, print lst1, print type lst2. And when you get good at this work, you won't be printing data types as much, but I am trying to build that habit of thinking about variables in terms of what type they are, because it's so much more effective allowing you to decide what operations can be performed on that type and helping you build effective search phrases when you have to research solutions, because you know what data types you're working with, therefore you can narrow your search criteria. But enough about me. When I run this, I can visually verify that both lists contain the same thing, and the data type of my new thing is a list. So I've met the spirit of the exercise. Before we move on to the next exercise, let's talk about why simply using an assignment statement might not be what we want to do. You'll notice up there in that comment I wrote, it's not that easy. This probably doesn't do what you think it does. I'm going to open a new cell just to focus on more code. And in this new cell, let's just start from scratch to make sure there's nothing up my sleeve and I'm not pulling any tricks on you. I'm going to create a brand new list variable, lst1. Not quite true. I'm just going to reinitialize lst1 simply to show you that it does have in it what we think it has in it. And then I will do that wonderfully deceptive and easy assignment statement that I told you not to do up above. What this really does is it creates a new reference to the same list. A reference being simply the memory location, in a nutshell, of where that list is. It doesn't make a copy of the data. It simply creates another reference in a different variable. Now we have a reference to that list in LST1, a reference to that list also in LST2. Those variables are distinct, but they both contain the same reference or the same memory address of the same list. And we'll prove that by writing a couple more lines of code. Let's append something to the first list, LST1, and we'll append 99. And then let's append something to the second list, and we'll append -1. I'm using the append function, which simply adds another element to the list. And then let's print both of those out again. Let's print LST1 and print LST2. That's going to give us some dramatically interesting results if we weren't quite expecting this, because the append statement operated on the same list both times, just using a different reference, or a different copy of the same references to be more precise. And wherever you see the word reference, just think memory location or memory address if you need to translate. That's why we can't simply do that wonderful, elegant assignment statement. We're not getting two lists. We're getting the same list pointed to from two different variables. And let's look at the other side of the coin. Let's say that now let's do the same thing, the same append with two different lists. And that's simply going to take us back to what we did in the original example. So LST2 is now going to be created by that list comprehension expression. And just to be clear about everything, let's reinitialize LST1. So LST1 is now 1, 2, 3, 4, 5, the way it was when we started. LST2 is created from scratch. LST2 now has a reference to a whole new list. LST1 and LST2 are now different. And then let's do our append statements again. I'll simply copy paste those, and I'll copy paste the print statements as well. Review that code before we execute it. We're creating a list 1, 2, 3, 4, 5. We're storing a reference to that in LST1. We're creating a whole separate new list using list comprehension and storing that reference in LST2. Now both lists contain the same thing, but they are physically different. Then we append a 99 to our first list, LST1. Then we append -1 to our second list. Finally, we print those out again. And you can see that the append statements only affected LST1 separately and LST2 separately. We therefore demonstrated they are not referring to the same list anymore. They're referring to two separate lists. That's just a bare bones introduction to the concept of a reference. And if you'd like to know more, please feel free to look that up in Python. That applies in other programming languages as well, C#, C++, Java. The concept of a reference is very important, and when we talk about how to deal with variables and how to pass them between methods and how to return them from methods and functions. So it matters to computer scientists, it matters to programmers. To you, I think I would suggest that you have a passing understanding of that word and you have a functional understanding of the difference between the list comprehension expression, which generates an entirely new list, and the assignment statement, which merely copies a reference. I wouldn't think you'd need to go any deeper than that. Moving on to the second exercise, create a list from the elements of a range from 1200 to 1000 with steps of 30 using list comprehension. And I've broken that down into two steps. The first step is to create the range. There's a range function that'll do that. And then use that range function in a list comprehension expression to build that new list. And again, I will give you a moment to do that. Pause the tape if necessary. I'm back. Let's look at a solution for this code. I'm going to paste in the entire solution and we'll talk about it. The first thing I do is create the range. The range, I guess it's a function. Maybe it's a keyword. My apologies, I don't know. It looks like it's in green just like print is, so I assume it's a function call. It takes 3 arguments. The first argument is your starting point. The second argument is how far you'd like to go in that range. And the third argument is your increment or your step size. And then I printed that because we haven't seen that before and we'd like to know exactly what a range looks like after we've created one. The next thing I do is use that range in a list comprehension statement. So instead of substituting in a list that we'd previously created, we can substitute in that range variable. And then finally I print out that new list. Let's run this little code. You can see that a range prints itself out as more of a thing than a sequence of numbers. So you have to be able to interpret that. And it looks just like the function call to the word range, which is very convenient. Starting point, ending point, and step. And then the second line of output is the result of our list comprehension, where we use that range thing, that range object, as the source data for the list comprehension expression. Let's add one more line to this. I'm curious about this. What data type is RNG? What data type is that variable that I created using the range function? That's an interesting question. And there you go. It is an object of class, I'm sorry, let me start over. An object of class range or an object of type range, whichever you prefer. So we've seen 2 interesting data types here. We've seen lists and we've seen range objects as well. Notice that the second argument to the range, I've been calling it a function, is not inclusive, so it's going to stop before it gets to 2000. You can see that it stopped at 1980. All right, let's move on to the next one. Use list comprehension to construct a new list, but add 6 to each item. Okay, we know how to make a new list. We've already done that. We need to tweak that code from above in the first exercise that we did to add 6 to each item. We're curving all the grades. Everybody gets an extra 6 points. All right, so take a moment and write that list comprehension expression, assigning it to LST2. I'm back. We know that it's list comprehension, therefore everything goes inside the square brackets. And we could say x plus 6 for x in LST1. You can see the plus 6 is applied to what we call the expression. And each of those elements of the list will be added, we'll have the value 6 added to it. And what do we get? There we go. Each element has been increased by 6. We could write this as a brute force loop, a brute force loop instead. So we could reinitialize LST2 to an empty list and then for x in LST1 colon temp equals x plus 6, and then LST2 dot append temp. Finally, after that loop is done, we could print it out again. Whoops. Let's see what we get there. Let's comment out this other print statement just to reduce the clutter. The only print statement now is at the bottom of that brute, or the outside of that brute force loop beneath it. It's not inside the loop. And I get the same answer. Those two do the same thing. The Pythonic way certainly is the list comprehension expression. It's much more compact, but if you find yourself thinking in terms of brute force loops, that's okay so far. If you're just learning Python and this is a very new thing to you, if you're comfortable with brute force loops, force yourself to drift towards list comprehension at all possible opportunities, because that is what you will see in everyone else's code. If we have an opportunity like this as a Python programmer, we'll solve it with list comprehension. The next exercise is using list comprehension, construct a list from the squares of each element in the list. All right, very similar to what we just did. Go ahead and take a shot at that. I'm back. We need to put some kind of list comprehension expression together, the results of which will be assigned to LST2, pretty much the pattern we've done in all the other exercises in this presentation. So the thing that we want to put in the list is each element times itself, so x times x, and then we can say for x in LST1. Instead of adding 6, we're just squaring x, x times x. Do we get something useful? We do. We get the square of each of those numbers in the original list. Now, there is no restriction syntactically on what to put or what to use as your expression variable, your iterator variable. And you can see throughout I've been using x if you scroll up in the other expressions. And x is convenient because it looks like an algebraic variable that you'd use in your algebra class, and it's easy to type. You could certainly use any other variable that conveyed more meaning if you like. We're a little stuck here because we don't know what this list represents. LST1, is it people's hourly salary, or is it their height, or is it their happiness factor? I don't know what it is. Therefore, using x here as a placeholder is reasonable because we don't have any context. But if I knew what those things were, I would probably choose a more descriptive name. I could just change those to y if the mood strikes me. As long as they're consistent, I will get the same answer. If I make a mistake and I accidentally type YY, then I'm going to get an error at runtime that says Y is not defined because I'm saying use YY as the next element in that list. Then when I do something on that element, when I perform that expression on the element, I'm not using YY anymore. I'm reverted back to Y, and I have a problem. That error message then might not be the greatest because, again, it says name Y is not defined. And that's true, but what the problem really is that this name Y doesn't match up with that variable that I'm populating. One of those has to go. So I will just change the expression to Y, and now I have all Y's, and again, it's perfectly happy and it runs fine. The next one says using list comprehension, construct a list from the squares of each element in the list if the square is greater than 50. Well, we know how to do the squares. We did that one in exercise 4 right above. But we now need to put in some kind of condition. We only want numbers in our new list if the square of that number or the square is greater than 50. So you need to think about that one. Look it up if necessary. Find a syntax you can mirror. Build yourself a nice search phrase, and then I will be back with you. Okay, I'm back. And the solution, I'll go back to using x again. X times x for x in LST1 if x is greater than 50. We've seen if before. We know how to build logical expressions and evaluate them with the if keyword. I guess green is keyword. So print must be a keyword, not a function call. Now let's try it. Does it work? I didn't get anything. My list is empty. The code ran, the syntax was fine, it didn't crash, but I got no results. I have a logic error. Revisiting my my assignment up here, it says if the square is greater than 50. Well, I was computing x being greater than 50. That means I need x times x in here. Try that. There we go. Now I only got squares that are greater than 50. It excluded the square of 2, 4, and 6 because those squares are less than 50 or less than or equal to 50. You can see that we added the if clause to that, and it followed that in clause. That might seem a little counterintuitive or backwards, but that is one way we can solve that problem. Let's make that into a brute force solution. So brute force this. How about that? Need a new list. LST equals open and close brackets 4x in LST1 if x times x is greater than 50 colon LST2 dot append x times x, and then let's test it out. Print LST2. As always, I will comment out that print at the top of that cell where we did our original print, just so it doesn't clutter up the output. And I don't know why I got this. I'm hitting some kind of key inadvertently that's running the cell. And therefore, you see that output there that I got midway through my typing. And I frankly don't even know what hotkey I'm hitting because I just don't have the habit of using the hotkeys in JupyterLab. But I will make that go away when I run the cell again, and you can see I get the same answer. Again, the brute force solution takes longer. You're more likely to make a mistake doing this because you may forget to initialize your list. So list comprehension tightens up the code. You'll get used to it if it's not something you're accustomed to at this point, and it's highly recommended that you spend the time to learn it. Our last one, given a dictionary that consists of vehicles and weights, I'm glad they told me that's in kilograms. Construct a list of names of vehicles with weight below 500. In the same list comprehension, make sure all the names are uppercase. Make sure the key names are uppercase. Now notice that we're dealing with dictionaries, so we have key value pairs. We can do list comprehension on dictionaries. It's still generically called list comprehension, but technically it's dictionary comprehension. Any iterable type is amenable to doing this, and we can iterate over a lot of different types. The name of the vehicle is the key in the key value pair when we study this data structure. So we have key colon value separated by commas. It's a dictionary because the visual cue is it's initialized with a curly brace delimited set of key value pairs, so you know it's a dictionary. And then we're going to use LST. We're going to create a list comprehension expression and iterate over a dictionary. So the square brackets still apply in our solving expression, but we're iterating over a dictionary. So I would still call it dictionary comprehension, I guess. People might disagree with me on that. But it does want a list. It does not want another dictionary. Now the only thing it wants in the list are the names of the vehicles. It does not want their weights. We're going to throw the weights away in this new list. We are going to examine the weights because they have to be below 5,000. But we're going to only include the names of those desired vehicles. What you need to do then at this point is build a search phrase. You're going to iterate over a dictionary and generate a list and make a decision based on the value of each key value pair in that dictionary. How about that? Does that make sense? So think about that one for a minute and I'll be right back. I'm back. Here's my solution. I used X again as my placeholder for the individual elements in the dictionary in the thing I'm iterating over. And that's probably not a good choice this time because I have some context and I'd rather give context to my variable names when possible. So we've been told in the exercise that these are the names of vehicles. Whoops, double clicked on that. So I could use a vehicle name for my variables. This helps me a lot actually. This helps me visualize what's going on because now I can see that I'm using the key in my expression. I'm using the key in the for clause because I know that when I iterate over a dictionary, it returns the keys using that syntax. Let's prove that. Maybe we weren't quite sure about that. So for x in dict, let's just do a simple iterate expression. By running this code here, I can see that all I'm going to get back are keys. And there they are. Sedan, SUV, pickup, minivan, van, semi, bicycle, motorcycle. And of course, again, that would be better served by using vehicle name in there just to be more descriptive. I could even add the comment to that if I'm not sure. Iterate over the keys in the dictionary. I could also use that key as a lookup value and print. So DICT square bracket vehicle name closing square bracket. Printing the key and then using the key as my lookup value to get the corresponding weight of that vehicle. And there's that. Sedans are 1,500, SUVs are 2,000, and so on. All right. Let me comment that out because it may be starting to clutter us. And then getting back to my solution to the exercise, I have an if expression in there, an if clause. I'm using the lookup with the key value into my dictionary to get the weight of the individual elements in the dictionary. I'm not done yet though, because the exercise said it wants the key names in all uppercase. And that would come into play right before I stuff them into this new list. It's not part of my if. I don't care if they're already in uppercase. But right before I make them into my list, I have to put them into uppercase. And I think that's dot upper, is it not? And it's a function call. There it goes. And if you weren't sure of that, that's another friendly neighborhood search engine exercise. How do I convert a string to uppercase in Python? Tack the dot upper function call on the end of the variable name, and that will convert it. That's a temporary one-time conversion. It doesn't permanently change the name of the variable. It creates a new copy of that variable for you that's in all uppercase. Let's look a little more closely at this code. I see a style issue that concerns me. Notice in the very first line of this cell, I'm assigning a new dictionary to something called DICT. And notice that that's in green. So that's a reserved word. And we're using it as a variable name, which is appearing to work. I mean, we got the right answer and it didn't crash, but that's not good style in any programming language to override the purpose of a reserved word and make it into a variable name. So a better choice would be to choose a name that's descriptive of what is in the dictionary and that does not already exist in Python. And you can see when I change that DICT to vehicles, it's not green anymore. It's black, the color of a variable name. And I'm going to need to go through and fix all references to that DICT, and there are several of them. And the code will still work if I got all of them, and I did. It still works. This is a much better choice. DICT, watch this. If I can create a new dictionary by doing that, so calling the DICT class constructor with open and close paren creates a new instance of a dictionary. And that's supposed to be it the way it works. Okay, but what if I had somewhere above that just accidentally used DICT as a variable name? See, now I have a problem because I overrode the use of that symbol DICT. I made it into an integer variable. And even it still showed up in green in that assignment statement, but it's no longer a dictionary type. It's now a variable name. And I can't, of course, call the constructor on that integer variable name. That doesn't make any sense. There is no constructor for an integer. If I comment out this line where I'm redefining DICT from its intended purpose, then this dictionary, this temp equals dictionary open close paren, that works now. I mean, take a look. You can see that I've got this big nasty error message here on this assignment statement, temp equals DICT open close paren, and that error is going to go away now when I commented out the line above it. Oh, it's not going to go away. It didn't go away, but I know why. Can you take a moment and try to figure out why the error didn't go away? I'm not lying to you. Everything I've told you to this point is accurate, but what happened kind of behind the scenes that is still causing me to get this error message? The reason is because even though I commented out this line of code, the environment persists and Python still has this definition stored. It knows what a dict variable is, and it knows it's an integer. So just commenting out that line of code doesn't uninitialize or uncreate dict. Remember, we have this behind the scenes chunk of memory called the environment, and it is keeping track of everything we do. Variable values, initializations, all the data that we've created to this point. So I need somehow to make this dict definition go away, to undefine it as an integer. And the easiest way to do that right now is just go back and show it to you in a completely different notebook file. Because I could rerun all of this. Well, let's just rerun all of this. What the hey, why not? So I'm going to rerun the whole thing. And I want to just point out the reason we're doing this again is because to show you that I can create a dictionary object using the dictionary constructor as long as I have not earlier redefined the name of that class to be some other weird data type. In this case, I redefined the dictionary class to be an integer by using the dict class name. So I'll run the whole thing again, and you'll see that this error does not come up. Restart the kernel. There we go. Okay. Restarting the kernel threw away, discarded, deleted the definition of dict as an integer. That allowed this line of code to fall back on the original definition of dict built into the language, and I created a dictionary. And to show you that, let's of course print that, the type of that. So print type temp, and we're going to see that it is a dict dictionary. And then maybe I'll take this one step further, just hopefully to clarify it a little more. Let's override dict equals hello world. Now dict is a string. Print that out. Dict is a string. Remember when I started life today and I opened up my computer, Python thought dict was a dictionary. Now it thinks it's a string. It also thinks it's a variable name. It doesn't think it's a class anymore. We've dug ourselves a huge hole here just by using poor programming practices. And then I can't use it anymore. This line will now fail. Temp equals dict will now fail if I run that cell again, because the thing that I put into the environment that redefined dict as a string persists in our environment. Let's run this again. We're going to get that nasty pink error message. There it is. And it's on line 4 again, telling us that we cannot do what we used to be able to do with dict because it ain't a dictionary no more. The takeaway from this is don't use reserved words as variable names, and be very careful when you rerun a cell because you've still got that environment behind the scenes, and you may not know or you may not be aware of the values of these variables when you start the cell. And that brings us to the end of this show. Thank you very much. Please post any questions in the FAQ.